In this lecture, we'll be looking at C++ basics. We will write our first C++ program that prints hello world on the screen. We will see how to compile and run a C++ program, print stuff on the screen, how to write comments, and primitive data types and variables. Here is our first C++ program that prints hello world on the screen. It has two statements, statement 1, statement 2. The first statement is a cout that actually prints the hello world message on the screen. The second statement is a return 0, which terminates the application. Remember that I gave you all the sample codes that I show on these PowerPoint slides. This example is o1 hello world slash ex1.cpp. So when you download all the sample codes that I have given you, you'll see this directory structure. We are now going through O2 basics. So press there, go there, and you'll see O1 hello world. When you go there, you'll see these 6 example files. The way to open this is not to double click in one of these example files and open it. That's not how you should do it. The way to open this is right click on the directory and then say open with code. That's going to open the folder rather than a simple single file. So now you can see all these example files listed on the left. Press on ex1.cpp and now you see the example that I showed on the PowerPoint slides appearing inside the text editor. The good thing about VS Code is you can use it as a text editor, but you can also use it as a integrated development environment. Now that we have our Hello World C++ application, the next question is how do we run this thing? Remember, C++ is a compiled programming language, which means that you need to compile the program into an executable file before you can execute it. The way to do it is open up a terminal. I opened up my terminal in here and say G++, which is the C++ compiler, and the name of the file that contains this source code, which is ex1.cpp. So press enter, and now you'll see that it has compiled and created an executable file. Name of the executable file by default in a Windows operating system is a.exe. You can actually see it here, right here at the top. When we try to open it, we cannot do it on a text editor because it's not a text file, it's a binary file. But we can do ls and see a.exe listed among the other files. So this is an executable, and the way to execute this is come into the command line again and type a.exe. And there you have it, hello world being printed on the screen. I should also mention that when you compile this program in a Unix machine, like the Linux machines that you have in your lab, or maybe you have a Mac OS, then the name of the executable that comes out of the compiler is a.out rather than a.exe. And in order to execute them, you need to type a.out rather than a.exe. Rather than have the compiler create a.exe and put the executable in there, you would usually want to specify the name of the executable file yourself. To do that, you say G++ -o and give the executable file name. Because I'm compiling ex1.cpp, it makes sense that I name the executable file ex1.exe. So I'm going to say ex1. But again, this is a file name, so you could specify anything to say AAA, XYZ, whatever. Let me do ex1 because I'm compiling ex1.cpp, and when you press enter, you're going to now see that ex1.exe is already created. Let me type it ls so that we can see both files. Here it is, ex1.exe. And look at the sizes. The size of this executable is exactly the same as the size of a.exe because they are the output of the same source file from the compiler. They have to, the executables have to be the same. To execute this, I simply type ex1. And there you have it, hello world being printed on the screen. I mentioned that VS Code is a text editor, but it can also be used as an integrated development environment. When we open the folder containing these example files, VS Code automatically creates some setting files and puts them under .vs Code, and you can see those configuration files. Don't worry about the contents of these configuration files. But Now we can use the VS Code editor as an integrated development environment and have VS Code automatically compile and even debug our programs. I can go here, press here, and you're going to now see debug C++ file or run C++ file. I'm going to run it. So press run, and now it's going to run the code. And you're going to see hello world being printed on the screen inside the terminal. You can also see the name of the executable, ex1.exe, being created. So what VS Code is doing in the background when we say run, it's basically running g++ minus o ex1.cpp, which creates the executable and then just runs it. And that's why we are seeing the output on the terminal. Now that we know how to compile and run a C++ program, let's go into the details of example 1 and dissect it. The first thing we'll look at is integer main, which is a specific label designating the entry point into our program. So if you think about it, any program implemented in any programming language needs an entry point. You have to specify the first instruction to be executed, right? So most programming languages, including C, C++, Java, and C#, they use a specific label called main that indicates the first statement to be executed. Other programming languages like Python or JavaScript, on the other hand, they don't have this specific label. What happens when you execute a Python or JavaScript program is the runtime environment takes the first statement and starts executing from there. The first statement in our main program is a cout statement to print the thing on the screen. So you could think of cout as a pipe that leads to the screen. So whatever the thing that you're putting on the right hand side of the cout statement will eventually appear on the screen. This smaller is an operator in C++. You could think of it as a redirection or pipe input operator that's taking the thing that you specified on the right hand side and putting it into the pipe so that it eventually appears on the screen. What we are printing here is hello world, the message hello world, which is called a string in C++, which is a sequence of characters. So any string that you have in C++ has to be put inside double quotes, as you see in here. And at the end of the statement, we have the semicolon, which marks the end of a statement in C++. This is a convention that a lot of other programming languages also use, such as Algol, Pascal, C, C++, Java, C#, and even JavaScript, although it's optional in JavaScript. It's a convention that you put a semicolon to mark the end of a statement. Another convention used to mark the end of a statement is to assume that the end of the line is the end of the statement, which is the convention used by programming languages such as Python. So if you learn Python later on, you'll see that you don't really have to put a semicolon at the end of a statement because the end of the line marks the end of a statement. But C++ assumes that you have to put a semicolon at the end of every statement. That's why, remember, we have two statements in this program, cout and return. As you can see, both of them are terminated with a semicolon. The next statement in our program is return 0. Return is a keyword in C++ that lets us return from the currently executing function into the caller. Because main is the entrance point of our programs, when we return from the main function, we are essentially returning back to the operating system, which starts the execution of our program. By returning 0, we are telling the operating system that our program has terminated without an error. If, on the other hand, you return a non-zero value, you are indicating to the operating system that your program is terminating with an error. The next thing we'll be looking at in our example program is the code block. As you can see, all steps or statements of our program are enclosed within an opening and closing curly brace. So we have got the opening curly brace here, closing curly brace right in here. This is called a code block. This is a convention that a lot of the programming languages, including C, C++, Java, C#, JavaScript, use to specify a block of code. The location of the curly bracket is not really important. It is just a style. And you should have your own style when writing your own programs. As you can see, my style is to put the opening curly brace on the same line as the function name and the closing bracket on a separate line. You would also see a lot of programmers use this convention where they put the opening curly bracket on a separate line like this, right after main, and then closing curly bracket on a separate line. Let's now go to the top of our program, where we see include IO stream. IO stream means input output stream and contains the definitions for input, C-in, and output, C-out streams. It must be included at the top of every C++ program if you are using C-in or C-out or similar IO streams, which are file streams. Include is a preprocessor directive to copy the definitions from. Well, you might ask, what happens if I don't include IO stream at the top of my program? Let me just erase it, save the file. As soon as I do that, you can see that VS Code is warning me, saying that cout is undefined. Let me show you that we're going to get an error when we try to compile this program by just recompiling it. So you can see that the compiler is now giving me errors. Basically, it's saying cout was not declared in the scope, and it's actually giving us a suggestion saying that std cout is defined in header IO stream. Did you forget to include it? So let me re-include it. There you go. Resave it. And now that error should go away. So let me recompile the program, and boom, as you can see, the program compiles. Bottom line is, anytime you make use of cout or cin, as we'll see later, you have to include IO stream. The last thing in our program is using namespace std. This is a statement that simplifies the code when working with the C++ standard library. C++ standard library contains various functions, classes, and objects that provide common functionalities such as input and output operations, data structures, algorithms. Again, the question is, what happens if I don't include this line at the top of my program? So let me erase this, save it, and recompile the program. So here it is. Immediately, the compiler tells us that cout was not declared in this scope. And it's actually making a suggestion saying that, is that what you meant? We know that cout is within the namespace of std. So without using namespace std at the top, this is how we are supposed to refer to cout. Let me now recompile the program, and you can see the error goes away. So without using namespace std at the top, this is how we are supposed to refer to cout, because cout is within the namespace std. Similarly, cin, minimum, maximum, there are a lot of other stuff that's defined within the namespace std. So if you don't include that line using namespace std at the top of your program, you have to refer to all of them by saying std column, cin, cout, or whatever. This is fine. You could do this, but it becomes cumbersome after a while. That's why people typically include using namespace std at the top, so that when they refer to things that are defined within std without using this prefix. You might also ask, I include using namespace std at the top, but I would still want to refer to things using this convention. Would that be an error? The answer is no. So you could still refer to cout as std column cout, just like in here, although you have already included using namespace std, and the compiler is not going to give you any error. So it's just a matter of convenience for you to refer to these things that have been defined in std if you're using namespace std at the top. All right, so far we know that we can use cout to print a thing on the screen. In this program, which is example 2, we have two cout statements. The first one prints hello world on the screen. The second one prints John Doe. When we execute this program, you're going to see that they come one after the other. So let me do that. So let me go in here and execute this program. Let me run this thing. Again, I'm using the IDE feature of VS Code. And you're going to see hello world followed by John Doe. Before we go any further, let me show you how to go step by step in our program in the debugging mode. So what I'm going to do is come here to the first line, As soon as I come here, you can see this red dot appearing. So I'm going to press it. This is putting a breakpoint in this line. Now, instead of running the program, I'm going to say debug this program. So what is going to happen now is the program is going to start and the execution is going to stop at the breakpoint line. So let me do that, and you're now going to see a yellow line appearing. So as you can see, this yellow line, and look at the arrow on the left hand side, which is indicating that the execution is now stopped at this line. So now I'm going to go step by step. So you can see the controls at the top. This basically says continue, which is F5, which takes you to the next breakpoint. Of course, I don't have any other breakpoints. If I press F5, the program is going to terminate. This is F10, which is step over. So this is irrelevant at the time. This is going to be relevant when we cover functions. So it's like execute the function without going into it. So this is step into. So if you have a function, you're going into that function. This is going out, and this is restarting, and this is stopping debugging. So I'm going to do F10 to go step by step. So when we execute this cout statement, we should see hello world being printed on the screen. So let me go one step, and now you can see hello world is appearing. Look at the location of the cursor after hello world is printed. It stopped at the next character after hello world. So that means the next cout statement is going to start printing whatever the thing that we are printing starting at this position. So let me do that. As you can see, the control is now at this line because you're seeing this yellow line, and the arrow is indicating that we are to execute this line, this statement. So let me do that, and you can see John Doe has appeared, and again the cursor just stops after John Doe, and when I execute return, the program is going to terminate. So let me do that. As you can see, the program has terminated. This is a great feature of Visual Studio that lets you go step by step over your program so that you could debug your programs. We have seen that when we execute these two cout statements, hello world and John Doe come one after the other on the same line. What if we want to print each one on a separate line, meaning that after printing hello world, I would like to take the cursor to the beginning of the next line and print John Doe on the separate line. There are two ways to do it. One of them is to use the new line character, which is \n, which is a special character in C++ and many other programming languages, indicating a new line character. After printing the new line character, the cursor is moved to the beginning of the next line. Notice that we can put the new line character inside of a string. So I can make it a completely separate string like this, or put the \n, which indicates the new line character, inside of any string. This program is exe3. This is our example 3. I'm going to go step by step, just like I did in the previous example. So I'm going to go into debug mode so that you can see how the messages appear on the screen. So let me go to the first statement, first cout. Nothing is on the screen yet because we did not execute cout yet. So let me do that. As you can see, hello world has appeared, but the cursor is still on this line because we did not take the cursor to the beginning of the next line. The next statement is a string containing only the new line character, which means when I execute this, the cursor is now going to move from here to the beginning of the next line. So let me do that. And you can see the cursor has immediately moved to the beginning of the next line, which means this string, when I print it, is going to start appearing from the first column of this line. And it also has new line characters in it. So think about it. It's going to print John Doe. Then the cursor again is going to move into the beginning of the next line. And then next line message is going to appear. And cursor will again go to the beginning of the next line. So we should have two more lines when we execute this statement. So let's do that. And you can see John Doe has appeared on one line. Next line has appeared on another line. And the cursor, due to this new line character at the end, cursor is now at the beginning of the fourth line. The second way to insert a new line character into the output stream is to use std_endl, which is a manipulator used to insert a new line character into the stream and also to flush the stream. So basically it ensures that the subsequent output appears on a different line. The difference between using the escape backspace n, which is a new line character, and using and l is that and l does more than just inserting the new line character. It also flushes the string. And so let's look at example 4, where I make use of and l manipulator. So what I did was I took example 3, where I was using the backspace n character to insert a new line into the stream and replace it with an L, which is basically doing the same thing. For all practical purposes, you can assume they are the same, although they are not exactly the same from a performance point of view. So when we execute this program, we should get exactly the same output as example 3. So let me again do step by step so that you can see that it's exactly doing what it is supposed to do. So this is the first statement, and just printing hello world. Again, the cursor is still on the same line. So when we do and L, it's going to take the cursor to the beginning of the next line and also flush the stream. So there we are. So the cursor is now on the second line. And when we execute the third cout statement, we are going to see John Doe on the second line, then next line on the third line, and the cursor will be located on the fourth line. So far, we have used cout just to print one thing on the screen. But it is actually possible to combine multiple cout statements into one, as shown in this example. So this is example 5, and this is the first line. Look at it. We have only one cout, then the redirection operator. So we have to print the first thing, which is hello world. Then I continue without, instead of putting a end of statement marker, which is semicolon, as you remember, I continue and say that after printing out hello world, continue and print and L, which is the new line character. Then continuous, again, put the redirection operator and say John Doe next line, which is the string right here. So put that on the screen and then finish it up by putting a new line character at the end. Remember, in C++, a statement ends only when a semicolon is put at the end. So as long as the compiler does not see the semicolon, it assumes that this is a continuation of the same statement. This actually lets us to break or spread out this first statement into multiple lines like this. So what I did was I took out this statement at the top, which where everything is written on a single line, and spread it out into 3 lines for readability purposes. So I can now clearly see that hello world is printed first, followed by and L, followed by this string. Remember, a statement in C++ only is terminated, ends, or the end of it is marked when a semicolon is encountered. So until the semicolon is encountered, the compiler assumes that everything up until that line is a continuation of the current statement. This is example 5, so let me just execute this, and you're going to see that this message is printed twice on the screen. So let's just wait until it's executed. So hello world, John Doe, next line. This is coming out from the first line, first statement, and this is coming out from the second statement. As you can see, they are doing exactly the same thing, but from a readability point of view, the second one looks much better. We are now moving on to comments. Sometimes as a programmer, you'd like to put comments in your code to explain what the code is doing. From the compiler's perspective, comments have no meaning. They're just ignored. They're just there as a programmer to remind you when you look at your program later on what you're actually trying to do in that code. So it is a good way to put additional information into the code so that when you look at the code later on, you understand what the code is doing. There are two types of comments in C++. Single line comments, which is anything that comes after double slash until the end of the line, is assumed to be a comment and ignored by the compiler. You could also use C-style comments, which is where C-style comments, and do single and multi-line comments. So anything in between slash star and star slash is ignored by the compiler. So you could write multi-line or single-line comments using this style. So here is an example where I have a multi-line comment at the top. So you can see these 3 lines are assumed to be comment and ignored. That's why the IDE, the Visual Studio Code, is coloring it with green to indicate that it's a comment and is ignored by the compiler. Here I am using the same style to write a single line comment, and I'm using C++ single line comment style by basically doing backslash backslash and then whatever comment I would like to write. So everything from backslash backslash to the end of the line is ignored. And here is the program to do that. That's example 6. It's basically, like I said, so this is totally ignored by the compiler, this is totally ignored by the compiler, and this is totally ignored by the compiler. So if I, it's as if they don't even exist within your program when the program is compiled.